When interviewers ask, "Can you explain bias and variance in machine learning?" they're testing whether you understand one of the most fundamental trade-offs in modeling. Here's a simple way to explain it. Bias is error that comes from oversimplifying the model. It happens when your model makes strong assumptions about the data and misses important patterns. High bias means underfitting. The model is too simple to capture reality. Variance is the opposite. It's the error that comes from overreacting to small fluctuations in the training data. High variance means overfitting. Your model performs well on training data, but poorly on new data. The goal of every data scientist is to find the sweet spot, a model complex enough to learn the signal, but simple enough to generalize to unseen data. You can phrase in one line. Bias measures how far our model's predictions are from reality. Variance measures how much those predictions change with different training sets. Show that you know this isn't just theory, it's how you make models practical. To really understand bias and variance, think of them as two sides of the same coin. When you reduce one, the other tends to increase. That's the bias-variance trade-off. Let's take a real-world example. Imagine you're predicting house prices. If you use a very simple model, say, a straight-line regression, based only on square footage, you'll miss important details, like location or number of rooms. Your predictions will be consistently off. That's high bias. Now, imagine you build a deep model with dozens of features, polynomial terms, and complex interactions. It fits the training data perfectly. Maybe too perfectly. When you test it on new houses, errors skyrocket. That's high variance. In real projects, we manage this trade-off by using cross-validation to estimate generalization error, regularization techniques like lasso or ridge to control complexity, and collecting more diverse data to stabilize variance. Interviewers love when candidates explain the why behind their modeling choices. So, if you're asked this question, don't just define bias and variance, show that you understand how they shape real-world model performance. Finish with confidence. In practice, my goal is to minimize total error, finding the right balance between bias and variance through careful validation and tuning. That's exactly what every hiring manager wants to hear.